We have one more term that we have to learn from section 7.1, and it's related to this idea of standard position, and the term is coterminal angles. Coterminal angles are angles in standard position that have the same terminal side. I think we've already seen some examples of coterminal angles, we just didn't call them that. So let's go ahead and do some exercises with this. So we get used to this. These words, coterminal angles. Exercise 20. Show that 45 degrees, 405 degrees, and 315 are coterminal angles. And what I'm going to do here is I'm just going to draw them all together in the same coordinate system and show that they have the same terminal side. 45 degrees, I know it's going to look like that. So there's 45 degrees in standard position. Now 405 degrees, I got to think about that's more than 360. So I'm going to take 405 and subtract 360. What I get is 45, which means 405 degrees is 360 plus 45. And actually that shows me right there that if I go full circle and 45 degrees more, there's my 405 degrees. So see, it ends up with the same terminal side. It's a different angle from 45 degrees because we go around full circle and 45 degrees more. And we also want to look at negative 315 degrees. Now, negative 315, I know I'm going to go in a negative direction. I know I'm going to go almost full circle, right, because it's close to negative 360. How close is it to negative 360? Well, to do that, if I just take 360 minus 315 and observe that's 45. Okay, so what that means is that the way I would think of it is negative 315 plus a negative 45 is going to be negative 360. So I'm just short by 45 degrees from negative 360. That means this has to be the same terminal side. So here's negative 315 degrees. So each one of those three share that same terminal side. They're coterminal angles. Let's do a similar kind of exercise now, but with radian measure. So we're going to show that 14 pi over 3, negative 4 pi over 3, and negative 10 pi over 3 are coterminal. These are all multiples of pi over 3, so I want to rely on my way of thinking of the multiples of pi over 3 as I go around unit circle. So these are multiples of 60 degrees, but we're thinking in terms of radians. So it probably is going to help me in this diagram if I imagine these red lines, like 60, 120, 180 would be here. So remember how we hit the x-axis with multiples of 60 degrees, but we do not hit the positive or negative y-axis. So 14 pi over 3, I'm going to think of as 14 times pi over 3. So I'm going to count out my multiples. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've gone 2 full circles. 13, 14, And I end up right there at that same as that 120 degree terminal side. So there's my 14 pi over 3. If I can fit all these guys on the same picture here. Negative 4 pi over 3. I want to move in a negative direction. Negative 1, 2, 3, 4. Yep, sure enough. There's negative 4 pi over 3 in standard position. Same terminal side. And now negative 10 pi over 3. I have to do negative 10 multiples of pi over 3. So let's just think about what that would be. Negative 1, 2, 3, 4, 5, 6 is full circle. Backwards, 7, 8, 9, 10. I end up in that same spot. So I got to do it in a negative direction. I'm going to draw a nice big circle here, go all the way around the outside of everybody else. That's negative 6, 7, 8, 9. There's that negative 10 pi over 3. So we can see from this drawing that each one of those share this same terminal side, so those three angles are coterminal.